Now, once again, let's think about the semantics of RPC. The client has made the call and the client is blocked. And since the client is blocked, we don't need to buffer the message on the client side. If the message gets lost for some reason, you don't hear back the result of the RPC from the destination in a certain amount of time, you can resend the call from the client side, and therefore you don't have to buffer the client side RPC message, but you can reconstruct the client side message and resend the call. Therefore, client side buffering is something that you can get rid of once again because the LAN is reliable. The next source of overhead, similar to the client side buffering, happens on the server side, and that is the server is sending the results and the results may get lost. LAN is reliable, may not happen that often, but it could happen. And therefore, we do want to do the buffering on the server side, because if we don't buffer it, then you have to re-execute the server procedure to produce the result. And that's not something that you want to do because it involves re-executing the server procedure, which may be much more latency intensive than simply buffering the packet that corresponds to the result of executing the server procedure. So you do want to buffer it on the server side, but that buffering on the server side can be overlapped with the transmission of the message. So in other words, the result has been computed by the server procedure. Now go ahead and send the result. While you're sending the result back to the client, do the buffering. You can overlap the server-side buffering with the result transmission and get it out of the critical path of the latency for protocol processing. So removing low-level acts, employing hardware checksum and not doing checksum in software, eliminating client-side buffering altogether, and overlapping the server-side buffering with the result transmission are optimizations that you can do in protocol processing, recognizing that the LAN is reliable, and therefore we don't have to focus so much on the reliability of message transmission, but focus rather on the latency and how we can reduce the latency by making the protocol processing lean and mean.